In this video, we're going to use the graphs of functions to help us reason about how the output of a composite function varies over certain intervals of the input. So this is a challenging task that requires two processes, and so let's walk through this. So I have the graphs of two functions f and g shown here, and we want to know how g of f of x varies over the interval from x equals 2 to x equals 3. So what we're asking is, as x varies from 2 to 3, how does g of f of x vary? So if x varies from 2 to 3, then we're going to use those input values as the input to f. So imagine x increasing from 2 to x equals 3. So x varies from 2 to 3. When x equals 2, f has an output of 6. So let me draw that in maybe purple. So when x equals 2, f has an output of 6. And then as x increases to 3, we notice that f, the output of f, decreases to 3. So as x varies from 2 to 3, the output of f varies from 6 to 3. So we can draw that change in f of x up here on the vertical axis. So x varies from 2 to 3, the output of f varies from 6 to 3. Now, when we're looking at g of f of x, we're using the output of f as the input to g. So if the output of f varies from 6 to 3, we can represent that variation over here on our horizontal axis for our graph of g. So this represents the input of g varying from 6 to 3. Now, if x, or the input to g, is 6, then the output of g is 9. And then the input to g decreases from 6 to 3, and while it does that, the output of g varies from 9 to 6. So we have this change of output of -3. So as the input to g varies from 6 to 3, the output of g varies from 9 to 6, which is a decrease of 3. So if we put all of this together, we could say, as the input of f increases from 2 to 3, the output of f varies from 6 to 3. And as the output of f varies from 6 to 3, and we're using that as the input to g, we're thinking of the input of g varying from 6 to 3, at which point the output of g varies from 9 to 6. Therefore, we could say g of f of x varies from 9 to 6. So g of f of x varies from 9 to 6 as x varies from 2 to 3. Now, varying from 9 to 6 is actually a decrease in the output of g of f of x. So in this case, over this interval from 2 to 3, the output g of f of x actually decreases. Let's do a similar thing, but look at a different interval. So let's see how g of f of x varies over the interval from x equals 5 to x equals 6. So again, we're thinking of using the input x for this function f. So x is varying from 5 to 6, which we could represent here. And as x varies from 5 to 6, we see, if we look over to our vertical axis, we see that the output of f is actually increasing from 3 to 6. And if the output of f is varying from 3 to 6, and we're using that as the input to g, then we're thinking of the input of g varying from 3 to 6. In which case, if we draw our lines up here and examine the output, as the input to g varies from 3 to 6, the output of g is actually increasing from 6 to 9. Therefore, we'd say that g of f of x varies from 6 to 9, which is actually an increase in that output. So again, this is kind of a hard idea, but you just think about the input to f varying by some amount and decide how f of x varies over that interval. And when you know how the output of f varies over the interval, you can use that variation as the input to this function g and think about how the output of g varies over that new interval.